Hey everybody, happy Wednesday. Let me go ahead and change my scaling real quick. I always forget that. So we're going to be diving back into the Data Lakehouse, um, trying to think of the word, not reinvention, that's probably a little bit too harsh. We're just sort of setting up a new way of handling our Delta Lake processing. So last time, let's go over to recents. Last time we were crafting uh, some of the new Silver Zone architecture, and we left off with the toasts table. We were also talking about whether or not you could iteratively walk through a workspace folder and manage notebooks from there. Um, from from everything I've seen so far in the documentation I've checked, you cannot do that. That's something that you'd have to do through the command line interface. So we're just going to set that up manually. It's really not going to affect much for us. Well, let's go ahead and reorient ourselves with what we were working on last time. So in Silver, we made it so that we have this notebook that creates a table called Untapped that has all of our date processing, and also we extract the venue data, the venue column. Before, we can show that before venues was a string, down here we've extracted venue out into an actual struct. So then we moved all this toasts logic into its own notebook. The reason that we're moving it out into its own notebook along with everything else is so that we can run this in a parallelized way. I'm going to go ahead and quit Teams too, just so I don't get any notifications. So being able to do that in parallel takes advantage of the cluster configuration that we have here, where we can scale dynamically between 1 and 4 workers. And we also have multi-threaded cores going on there. So just keep that in mind. Okay, so let's get back into it. So with toasts, we see that we're reading in the Delta format from this base table called Untapped. If we wanted to, we could also just read in from the registered Hive table. I'm just doing it this way for the sake of convenience. So then we actually don't need this. So then we go ahead and flatten the toasts data frame, and then clean up the column names, and then write it back out. So let's go ahead and document that real quick. So you'll see in flat, let's actually show this too. So what this is doing is it's walking through, and whenever it encounters a nested object like created at, it'll do items underscore created at, or items underscore user underscore bio, right? And what we want to do is go ahead and remove items from this and go ahead and bring them up a level. So that's what the cleanup process does. Okay. In this write delta table function we were working on last time too. So this is going to use our delta table logic to do a merge, or really an upsert. Okay, so we can now remove toasts from here. We'll move over to venue. There's one last thing I want to check here. Just adding some more documentation here. And we're doing this because it just makes it easier to navigate our notebooks and see what's going on. Taking advantage of the markdown syntax. Okay, so now, like I said, we're going to move over to venue. So I'm actually just going to take toasts and clone it. Since we already have some components we're going to want to use consistently. So we're still going to read in the untapped data, but we're going to be using the logic we've written for venues instead. So over, where is it? I guess because of the clone. Let me reopen Silver. So this is the logic for venues we're going to want to use. It's been commented out because it was causing a bug in this initial run. I think we're going to fix this with the way we're restructuring the logic. So let's uncomment this. I'm going to clean up this logic just a little bit to make the notebooks consistent. So we're going to select the venue, and then we're going to use this. So then we should be able to borrow from toasts to get this. So I'll show you here in a second once I grab this. Yeah, it's clean and flat. That's what it is. So what we're doing here is we're iteratively walking through the data frame and doing the same cleanup that the flattening clean or clean flat column names does for us. So we're essentially just doing it manually instead of using our function. But since we now have this library in place, we should really do it that way. So I think this is going to be venue. And then let's go ahead and run this and see where we're at. So we're just waiting for the data frame to load. I'll look at this next. Not sure why this is taking so long. I mean, I might need to look into cleaning that again. Because last time we did a vacuum and clean. Okay, it looks like it should be done. Okay. So then once we run this, we can see in dfvenue flat, everything is prefixed with venue. So we'll go ahead and take advantage of the clean column names by running this function. There we go. So then we'll clean this up. So whenever we see dfvenue flat, we'll use dfvenue flat clean instead. Okay, so that works. And then for this, we'll do the same thing. Let's see. So this is just exploding down a level. For lack of a better name. Okay, so that should be fine. We don't need to register anything. And then we're wanting to write this out. And the primary key for venues is venue ID. Yeah, and if it wasn't for this manual renaming exercise, I think a lot of this could probably be consolidated. But you know, we need to know like the prefix, the prefix that gets created here. So that might be something I do eventually. Is restructure some of these notebooks to run based off parameters. But I kind of like in Silver being able to have control over the transformations and making sure that they all conform. So that's just something I'll have to think about. Okay, but it looks like venues is good to go. So we'll go ahead and clone this and move over to, actually before I clone it, I need to see what the next subject is. So we'll take badges. So we'll go ahead and process up to here. Actually, So something I'm curious about is whether it would take longer to do these steps separately or together. Essentially, the extraction of the data from the data lake, and then extracting like the column name and doing some of the flattening, or whether that's something that we could do as one step and save some time. So I'm going to go ahead and look at how long it takes, and then I'll restart the cluster and do it again, all consolidated. So let's run this. And then let's see. I wonder if that's because this is already loaded. Just to make everything consistent, I'm going to go ahead and restart the cluster. It shouldn't matter because of lazy execution, but we saw in like venues, it took what? Yeah, almost a minute and a half to read that in. So let's go ahead and do our test. So this is going to be, let's go ahead and make it display just so we get, I guess I don't even really care about an executor. Let's see. Because really what we're worried about is the time it takes to execute, before the write. I don't necessarily care how long it takes to do a display, but I'm just going to leave that in there just in case. So we'll have df test equals so here we're doing our read and our select and flattening all in one step. Okay, so our cluster is back. Yeah, so I think it's just the first time that this reads in is going to end up being slow. Yeah. So we'll restart again, and then we'll do our test. So this was basically 40 seconds. Which isn't too bad. But I still think we can do a little bit better. Let's actually go into Azure. Because we did that vacuum and clean the other day. I'm interested to see what that looks like. Because if we're loading a bunch of small files every time, that would be why it's running so slowly. Yeah, so we have just a ton of records in here. So I'm going to look at that vacuum and clean option again. Let's run our test first. So we should expect this to take the same amount of time. That's my hypothesis. But if I was right all the time, this wouldn't be very fun. Just so everyone can see. Oh, okay. So we'll change this to be so we're just replacing all of these explicit column calls with a call to the call function. We should be fine. So let's see. Okay, so we need to unfortunately restart our test because it clearly already cached the data frame, or sorry, the delta table in memory. But let's go ahead to let's create ourselves a little debug notebook because I'm going to do some cleanup on these tables too. Okay, it's already the 19th. Wow. Okay, let's link this to I hate how it loses our GitHub initialization. Seemingly every time I go to do it, basically. So let's see. Okay. So back over in we were in badges, so I'm just trying to get back to that. Oh well. There we go. Okay. So we're running up through here, and then we're going to run our test. This is sort of a scattered stream today, but anytime I'm waiting on the cluster to reboot, I don't necessarily just want to like be sitting here staring at it, you know. Okay, so remember our hypothesis is around 40 seconds for both. And it looks like the execution plan is the same. Yeah, so that's well within our margin of error. So we can be comfortable that this doesn't really matter. So we'll leave it be. So this 40-second time, though, I'm not really a huge fan of. So before we move on with badges, I'm going to try and fix that. So keep in mind, our issue here is that we have a ton of really small files. So, 348. So what we're going to try and do is vacuum these tables. So back over in our vacuum and clean, and then we know that we can, in SQL, what is the command? Let's try optimize first, just to see, because that might, or rather, that should go ahead and compact all the files. And then, let's see, we'll do it for untapped. And we can try and cache this too. Like that might be something that I go ahead and do as part of the Silver notebook. So we'll explore that. Because ideally we kind of have this data hot before we go to read it in. But we'll see down here if we looked, yeah. So we removed 345. So let's see, files removed, min, max, okay. So then if we go back and look at this now, so the optimization ran, we can see that here, yeah, we can see that this should be the like consolidated version, the most recent write. So then if we go back over to badges, and let's actually, before I do all this, let's run a vacuum too. I'm just looking at the syntax. And this is something where we can change the retention period too. That's something that we'd have to kind of look at in runtime. But over here we can do vacuum. That's how you spell vacuum, right? Yeah. Oh, I can't spell. looking at the documentation, and I swear I saw, yeah, there's two C's. So there's somewhere some eagle-eyed observer can find in the Databricks documentation a misspelling of vacuum. And that's my story, and I'm sticking to it. So what this is going to do, so optimize compacts your files, and it kind of walks through and re-optimizes it according to your partition plan. What vacuum is going to do is check in the Delta log, and any of these files that are no longer being tracked, like maybe these ones from last October aren't being tracked anymore, right? It's going to go ahead and mark them for deletion so that they're no longer being tracked. And that'll make it so that when we're reading in this data, instead of having to do a full scan of that directory, we can read less files to bring in our data. And I'm going to go ahead and set up the table to be auto-optimized too. And really, if we wanted to do this, like ideally, we would look at some sort of histogram and see the value counts. I think I actually have handy. Yeah, I've got this. I've got our Power BI open. So let me show you real quick what that would kind of look like while this runs. I don't know why Power BI is asking me to log in like every time I open it now. Maybe I'll quit it and restart. Okay, right as our vacuum finishes. So now if we go over here, we'll see, let's see. So I think, yeah, our Delta log changed, and then if we go ahead and query this now, over in badges, with a fresh cluster, we should see our 40-second number drop a little bit. Oh, I think it's because my my password changed. I'll mess with this later. What I wanted to show you is in transform data. And I guess we'll have to re-credential everything because I'm not signed in. In your preview up there, you can see the cardinality of different tables. It's one of your view options. So we would be able to see in the untapped table what columns are well distributed for a Z order or a partition scheme. So we'll dig into that later. We've got a fresh cluster. So let's run this again. And we're expecting a time of less than 40 seconds on this run. That would be our goal. Still taking its sweet time. Yeah, about the same. So this is probably a limitation of our partition plan, in the sense that we don't really have one. So because of all these tiny little files, we're probably just going to be stuck with this for a little bit. When we go ahead and move on to finalizing this new architecture, one of the things that we will talk about is how to better partition something like this, especially coming out of bronze. Like I mentioned, I am going to go ahead and turn on a function to auto optimize our tables. This is provided by the Databricks runtime. So we'll give this path, and actually let me just use the actual table name. We're just going to turn on an auto optimize on write. But if we wanted to figure out our like ideal partitioning column, that's something that would speed this up quite a bit. It's just not something that I've really prioritized up to this point. So if you look at if you look at this table, so we don't have that many rows, but this is all semi-structured data, so it's kind of hard to optimize. The only field we have is check-in, really. We could partition by date if we wanted to, but this is a date time. So that makes it tricky too. So, like I said, this is something that I am going to consider, like before we move away from this, before I consider this complete. But it's really not something that we're in a great position to do right now. One of the things that we could probably do is over in bronze. Ahead of our write, we could add a partition call. Where is it? Down here, right before I write to Delta Lake. One of the things that you can do so our cluster is live, but we don't have a data frame brought in, so we can do that real quick. So we'll grab our schema too. There we go. So here, if we wanted to, we can partition by. And one of the things that this accepts is a column string. So if we wanted to we could go ahead and create a new column like specifically for date that doesn't use the date string. Part of the problem is we don't actually turn that date into something meaningful until this date fix logic in the silver zone, if I recall correctly. So if I go over to here and I'm looking at my date, yeah, this created at is still a string. So there would be a little bit of work required to make that happen. But if we wanted to, we could make that string a date, extract that, and then we could partition by year, month, day, and then that would probably clean this up a little bit. I would probably do it by year, month, just so that we don't have even smaller data volumes. But those are our options. So we'll keep looking at that throughout. I just noticed that this was ingesting kind of slow and wanted to explore that before we lost opportunity. So working back on badges, we'll grab the same logic that we're using over here for badges in silver. Just bring it over. Okay. And then so df badge is flat. So let's run this real quick. Okay. So this is actually using an older older piece of code too, where we're manually extracting all these fields. So I'm going to go ahead and comment this out, and I'm going to have us use our new flattening function. So we want to flatten df badges. Cool, and then so this is going to take this and then items. Cool. So we can then remove that. And then the only other thing that badges does is a Writeout. This is using an older piece of logic too. I think badges was one of the first tables that we ever created. So we're just actually going to steal our code from toasts to load into the data lake. Let's make sure that this got cool. Okay, and then our primary key is badge ID. So that's actually, that brings up a concern. So over here, so over for venue ID, it's a true venue ID. For badges, one of the things that we're keeping is check-in ID. Now, this should be a table for just badges. It shouldn't have check-in ID. So we're going to have to modify that. So this should be badge ID. So if we look at this real quick. So we see that this this should be unique. Yeah, whereas we know that this shouldn't be, right? Because you can have multiple badges per check-in. I just kind of don't like that. So I'm going to fix that real quick. So we're going to drop the table. And then we're also going to delete the data. So it should be at, what's the name of that? Let me go over to silver. The true is to make it recursive. Okay, so this deleted all the data. So if we select from here, this isn't going to exist anymore. So now we'll remove this. And this will screw up our data model a little bit. Power BI wasn't working anyway, so I can't show you how. But that's fine. For each so for each entry in the fact table, we should be able to get back to badges. So if we look at let's look at our list of tables. So we have fact badges. So then yeah, so that's fine. So then if we go back to fact or facts, for each check-in ID, we can get to facts badges, which will blow it out and then let us find that particular badge. So this should be fine. I just wanted to double check. Okay, so we're gonna write this out as badges with a primary key of badge ID. Let me make sure that this got cleaned up in. Yeah, Vinny's is good. Wanted to make sure I copied the data frame name over. Okay, so then all we need to do is register Delta table. And then the name is going to be badges. Cool. Okay. So let's do one more here real quick. So let's clean up badges. Yeah, so we can do beer real quick. Okay, so we'll go back over to our silver and we'll grab this. This we need to redo in the same way that we did badges. So okay. So then this is where we were doing the cleanup. So I'm going to go ahead and remove that for now. And then I'll have df beer flattened clean is equal to this. Okay, so this should be beer. And then this can be called active. So we'll have this be active bool when this we don't need to do a drop. change that. Cool. Then our primary key here will be BID. Oh yeah, we changed some of those names. So let's look at so we have ABV, label, name, slug, style. Okay. So we'll just do I think I can actually just steal this. So we want it to be called beer ID. Huh, okay. Okay. And then let me check something in gold real quick. Okay, now I see. No, I remember. So the actual registration is happening with Gold Zone. It's been a while since I was in there, I guess. So what we want to do instead is we'll go ahead and read in this actual schema. So this should be where was that path? This plus beer. So it'll be spark.read.format delta and then dot load. And then we can see the schema for the silver zone. So that was our problem. But I think it just needs to be changed to ID. We're just going to double check instead of goofing around and guessing. So it's beer BID. And has had active style. Okay. So this should be beer BID. Cool. Okay. So that is beer, or the beer table. So you know, we've made pretty good progress. We still have some to bring back in, but really, you know, we're mostly there. It's kind of just repeating the same ideas. We kind of got derailed with our little Delta Lake loading experiment, but you know, I am a data scientist after all, so it happens. Thanks everyone for tuning in. I'll be back next Wednesday to keep moving along on this restructuring effort. Thanks for